So for this video, we'll be discussing sphingolipids, which differ from glycerolipids, as we've discussed, in that instead of its 3-carbon backbone being provided by glycerol, in this case, it's provided by serine. 2 of the carbons are provided by serine, fused with the 3rd carbon provided by palmitic acid, which is a 16-carbon fatty acid chain. So this molecule here is called sphingosine. So sphingosine, again, is just this serine with palmitic acid. Sphingosine can convert to a different sphingolipid if this nitrogen here participates in an amide, this amide bond here, and creates a molecule known as ceramide. Ceramide is a precursor to one type of sphingolipid known as glycolipid, or glycolipids. So those sphingolipids are divided into 2 branches, glycolipids and sphingomyelin. So sphingomyelin differs from this in some ways. It's very similar to phosphoglycerols, specifically phosphocholine and phosphoethanolamine. So let me just draw that here. So this hydroxy group will contribute to a phosphate here. Which will be bonded to, I'm just going to write either, I'm not going to, or ethanolamine. So it can either be bonded to choline or ethanolamine for its functional group, but all else remains the same. Of course, phosphoglycerols such as phosphocholine and phosphoethanolamine don't necessarily have to have this palmitic acid here, whereas a sphingomyelin does. So this is called sphingomyelin. And this fatty acid chain here, fatty acid, has to be a very long chain, excuse me, fatty acid. I'm abbreviating FA for fatty acid. So this is very similar to phosphatidyl choline or phosphatidyl ethanolamine. The only difference being this backbone isn't provided by glycerol, it's provided by serine. And that's, so of course, since it's not provided, since it's provided by serine, we have this amide bond, which wouldn't be possible with a glycerol molecule, as it has no hydrogens to contribute. In addition, we have a very specific type of fatty acid here called palmitic acid, which, let me just write that down. Palmitic acid, which is a 16-carbon chain. 16 carbon chain. So like I said, the second type, so this is one type, so type 1. So that's one type of sphingolipid called sphingomyelin. A second type is derived from ceramide, as I drew earlier. Just fix that. So it's derived from ceramide, which basically looks like that. So this is ceramide. The only difference the only difference being that there's no phosphate group here. So this is ceramide. It's possible for a sugar to attach to this hydroxy group here, and this sugar can be glucose or galactose. So if glucose or galactose attached to this primary alcohol here, we create what is known as a glycolipid. Because it is a combination of a sugar and a fat. So sugars that contain, glycolipids that contain either glucose or galactose are going to be called cerebrosides. So these are called cerebrosides. And if it contains glucose, it would be called a glucose cerebroside. Glucose cerebroside. Or if it contains galactose, it would be called a galactose cerebroside, but I won't write it out.